Okay, one of the reasons I love Trig is that there are so many applications in the real world that can be modeled using a sinusoid. And so that's what we're going to do right now. We're going to go back a couple of chapters to where we graphed sinusoids, and then we're going to take it one step further. We're going to answer some questions about those sinusoids. So the first thing I want you to be aware of is that in this section we are strictly in radians. All right, so here's our story problem. On one particular July 4th in Brooklyn, New York, high tide uh, occurred at 9:36 a.m. At that time, the water was 2.7 meters deep. Low tide then occurred 6 hours later at 3:36 p.m. and the water was 2.1 meters deep. And so your job is to find the sinusoidal equation, and you'll remember the first place that we start is we always start with a picture, that we draw a sketch. Once we do this, it will be really easy to find the equation, and then we're going to answer the two questions. This is the new part here, and this is going to connect to what we've been doing with solving. All right, so here we go. First thing I had to do was I had to change 9:36 from hours and minutes to hours with a decimal of an hour. Okay, so I went ahead and took 36 divided by 60, and I found that high tide was at 9.6 hours a.m., and I started there. And then I went to low tide, and again using 336, that turned out to be 3.6 hours, but because we're afternoon, I'm going to add the 12. You've probably heard people talk about military time, and that's what I did here to get 15.6. Okay, so the next point on my curve is 15.6, 2.1, and then I can see very easily that 6 hours went from high tide to low tide, and so it's reasonable to expect that at 21.6, which would be 11:36, 6 hours later, we'd be back at high tide. So I drew a smooth curve, and I found that it was a cosine curve, and so I'm ready to go and find the four values for the y equals. All right, so I've got the work done here. Let me go ahead and go through with it. We always start with the midline, and the midline is this middle point, middle line, that is halfway between the high point and the low point. And so what we do is we add the y's together, divide by 2, and we find that 2.4 is the number of meters that represents the midline. Okay, the amplitude is how far we travel from the 2.4 up to the 2.7 or down to the 2.1. Mathematically, the way we find that is this time we subtract them and divide by 2. We get the amplitude to be 0.3. Okay, we need to talk about the period. We already talked a little bit about that. We said it was 6 hours to get from high to low, and then another 6. So I think that you can see that the period is 12. 12 doesn't go in the equation. What does go in the equation is the c value, and the way we find that in radians is we take 2 pi and divide by the period. So this is our c value. Last one is the horizontal shift, which is as simple can be. It says high tide is at 9.6, so we are going to shift 9.6 to the right. And now we're going to put those four values into a sinusoid. So here we go, midline plus the amplitude. We're talking about a cosine. And then the c value, pi over 6. And then here is how we write 9.6 meters to the right. Okay, so none of that was new. This is from another chapter. We've done it before. Okay, here is the new stuff. First thing we want to know is what will be the depth at noon. And so noon is 12 o'clock or 12 hours. And really it's as simple as putting it into the equation and then just letting your calculator do the work. And so you might want to try that and find that you have 2.493 meters at noon. Okay, so that's pretty simple. That's not solving, that's evaluating. Here's the part that's going to be tricky. All right, so now we're saying we want to go back here and imagine a line drawn at 2.5, and we want to know after 9.6, what are the first 4 times that the tide will be a depth of 2.5? So in other words, we're setting y equal to 2.5. So we're going to go ahead and solve this equation, and we're going to find not one value, we're going to find 4. Okay? So here we go. You ready? So I just want to make you aware that it's the x we need to get by itself, right? And then the other thing I want you to be aware of is that this period tells us how often we will, sorry, this is the C value, and the C value that gets us to a period of 12. We're going to remember that the period is 12, and that will tell us how often the values repeat. So the first thing we're going to do is subtract 2.4 from both sides, and we get zero point 0.1 is equal to 0.3 cosine pi over 6 x minus 9.6. Okay, dividing both sides by 0.3 gives us that 1/3 is equal to cosine pi over 6 x minus 9.6. So you recall in class we had equations to solve that were similar to this. I don't believe we've had the minus, plus or minus in parentheses with the x, but we're not going to worry about that to the very end. It just means that the very last step we're going to add a 9.6. All right, so what we want to do is take the inverse cosine, right? So the inverse cosine of 1/3 turns out to be approximately 1.231. So we're going to set that equal to pi over 6 x minus 9.6. Now, this is really important to remember. We know that the cosine is positive in the first and fourth quadrant. Okay, so the cosine is 1/3 here and again here. So when we get this as an answer, we need to then take 2 pi minus that 1.231, and that turns out to be approximately 5.052, and that is also going to be equal to pi over 6 x minus 9.6. All right, so we really do have to solve both of these equations to get the first two values. All right, so from here we're simply going to multiply by the reciprocal, so 1.231 times 6 over pi gives me 2.351, and that's equal to x minus 9.6. Ooh. And so, like I said, the last step is going to be to add that 9.6. And so what that means is that at 11.951 hours, which if you multiply this by 60, let's see, I had it written down, would be approximately 1157. The depth is 2.5 meters. Okay, that's the first one. Right, we're going to continue same manner, multiply by pi by 6 over 5 pi, so 5.052. We're going to multiply that by 6 over pi, and then we're going to add the 9.6, and at the end of this one you should get 19.249, which when you change that to hours you get 19 hours and 15 minutes, and so at 7:15 p.m. We would be again at 2.5. So now we need to talk about the other, right, 2 times, because we asked specifically what the 4 times were. This is where the period comes in. We know that each value we will hit 2.5 meters every 12 hours. So it's as simple as adding to the 11:57 12 hours and getting 23:57, and then adding 12 hours to this. Let's go back to the 1915 so it makes more sense, 31.249 hours. Okay, and we could change those to times as well, but we're not going to bother doing that. Okay, so that's how we find the other two. That's when the period comes into play. This is a lot to remember. We have a couple of days to work on it before the test. See you in class.